Alright, hey there, today we're going to be talking about probability, and we're going to be talking about two specifically, theoretical and experimental, and we're going to be comparing the two. So before we get started, you're going to want to make sure that you have your handouts, this handout first, and then throughout the video you're going to need to pause it, and then whatever I have written down you're also going to want to write down for your notes. So to test probability we have to have an experiment. And in each experiment, every time you do it, we call it a trial. And then every trial has an outcome. So if you could think of it, you have a giant experiment in which you run multiple trials, which there could be multiple outcomes. So a set of one or more outcomes is an event. And so we like to represent probability in mathematics with a P and then whatever the event is inside. Usually it's shorthand because we're lazy and we don't like to write much. And then they show you here in this diagram that the 0 is the probability of nothing happening. It's impossible that it's going to happen. So for example, Mr. Ashcraft is going to go back in time. There is a 0% chance that that's going to happen. Right? The probability of that happening is 0. It's highly unlikely. It's impossible. Right? And then 1 is certain. So probability of 1 would be that you are here listening to the video, right? Or that you are going to graduate from the 8th grade, right? It is certain or highly likely that those things are going to happen, right? Or the sun is going to rise. And so hopefully that helps you understand that what the P stands for, and then the event, and then what 0 and 1 stand for inside that. So if you look at the bottom of your notes, they use an example of rolling a cube, a die, right? And so I put the shorthand here off to the right. I'm going to have to move it a little bit, but you can see for event A up there, probability of rolling a 2, 4, 6 is 0.5, which could be represented as 1/2, which could be represented as 50%. In the B, right, rolling a 5 on a number cube, there are 6 possible outcomes again, and so that's where I have the 1 is what I want, the probability of getting a 5 over 6, which is the same thing as 17%. So whether you demonstrate it as a decimal, a percent, or a fraction like I've done here, they're all the same thing. They all mean the same thing. So this is where you're going to want to pause the video, right? You're going to want to pass out the packet, rock, paper, scissors, and you're going to want to put your name on the packet. So once you're ready to do that, you're going to want to push play. So on your packet, the first page you should see is activity sheet 1. So we're going to test this experimental and theoretical probability by playing rock, paper, scissors. So before you guys get started, the first thing you want to do is make sure your name is on it, and then make sure that you read the instructions on how to play rock, paper, scissors if you don't know how. And then the first thing is that when you're playing the game, it's 45 times with a partner. So that means that the total tallies amount that you should have would be 45. And after you add up all the frequencies, it should total 45. So your name is going to go under player A, your partner's name is going to go under player B, right? And both players need to keep track. And then the tallies, right? Hopefully you know how to make a tally. And then the frequency is just all of the tallies added up in number form. So after you do that, and you've answered question 2 or 3, then you're going to go to a different partner and play the game 45 more times, repeating the same thing that we did in part 1 of this sheet. So you're going to go ahead and do that. Once you're through with that, right? Once you're through writing all of that, you're going to want to pause this, right, and complete the first page by doing all the activities, right? And then you're going to want to move on. So go ahead and pause now. Okay, so you've done activity page 1 now, and now you're on activity sheet 2. So we're going to use the math behind keeping track of all the data that you just kept. So if we're in question 1 here, you're going to want to write this down, and I'm going to explain this table. So what it says is if player chooses rock, paper, scissors randomly, each of the 9 outcomes in the table below is equally likely. Fill in table with A if player A wins, B if player B wins, and T if it's a tie. So what you do is player B has rock, paper, scissors. Player A also has rock, paper, scissors as their choices. So if player B throws a rock and player A throws a rock, right? Not literally throwing it, but in the game, there would be a tie. So the winner would be a tie. If player A threw paper, right, and player B threw a rock, paper covers rock, so A would win. If player A threw scissors, right, and player B threw a rock again, right, player B would win. So you're going to fill in the rest of this table, right? Hopefully you're writing this down, and you're going to want to put this off to the side because it's important. You're going to want to see how many times player A wins, how many times player B wins, and how many ties there are possible when you play rock, paper, scissors. So I'm going to jump down to the third part. Right, you guys will have time to complete this after I'm through. So in the third part is what we call a tree diagram, right? And so R is going to represent rock, P is going to represent paper, S is going to represent scissors. And so you're going to complete the outcomes with R, P, or S, right? So player B, right, and player A is what we have here, and then the outcome. So player A would throw an R, and they have and player B has the option of throwing R, P, or S. So you would want to put that in these blanks, which mine are a little misaligned. And then the outcomes would be RP and RS, because player A could throw a rock, and then player B could throw a paper, player A could throw a rock, and player B could throw a scissor. So once you're through with that, right, you're going to want to go to question 4. You're going to want to complete all of the table before you do that, because in this page and the next page, you have to answer questions using the table and the tree diagram, right? And make sure you look here on this question, on question 4, it says which format, the table or the tree diagram, is easier to interpret and why. So you're going to answer all of these questions. So go ahead and pause the video now, right, and make sure you complete that page before moving on. Alright, so hopefully you've been pausing and moving through this video while you are completing all of what's going on in this packet. So activity sheet 2 is the front of page 2 now. Here we are, and you're going to answer these questions by using the page previous, right, and everything that you've done on this page so far. Hopefully you completed it, right, and you're going to answer these questions, right, using the table. And make sure in C and D you have to use the table, not the tree diagram. Moving on, right? So you're going to want to complete that before moving on. So make sure if you haven't, you pause the video now before pushing play again. Alright, so now you're going to play it with 3 players and having these rules, right? So player A wins if all 3 make the same hand and shape, right? And so you can read on for how player A, B, and C wins. The important thing is that you each declare in your group of 3, right, who's player A, who's player B, and who's player C. And you're going to want to know how you win. And then everyone needs to keep track of the tally and the frequency, right? Make sure in question 4, right, you're going to go back to page 1 to compare and contrast the 2-player game and the 3-player game. You're going to look at the table from page 1 and see how it compares to this page here. So make sure you pause the video here and complete the back of page 2, and make sure answer questions 3 and 4. Again, hopefully you're doing all the pauses throughout this video, right? And in addition to the pauses, hopefully you're writing down the things on the side that I'm trying to give you. So this is maybe the most confusing page of all of it. And so in this last page, you're going to want to fill in this giant tree diagram with the 3 player options. Notice player A, what their options are, player B, what their options are, and player C, what their options are. So I've done the first one for you, right? So player C is going to be RPS going down, and then the outcomes are RPS, RRS, right? And so from here, you're going to want to make sure that you're right. Player A wins, player B wins, and player C wins. And so if player A wins when all 3 are the same, so in this first one, right, player A would win. In the second outcome, player C would win. And in the third outcome, player B would win, right? Because it has to fill those requirements for either A, B, or C to win. Then you're going to answer these questions down below. So you're going to want to pause here and maybe replay the video starting from the last page, or if you didn't pause at all throughout this video, right, you're going to want to pause where each section is and there's a pause. So once you're finished with this, you're going to give your completed pack to the teacher and make sure your name is on it. And we're going to come back to this and talk about experimental and theoretical probability. Thanks for listening.